This is going to be the shortest presentation I've ever given in my career. 3 slides.
3 hours?
That's all. All right. So I thought about a lot of different things that we could talk about here. And the refrigerants technical or regulatory presentation that I give, which most of you have seen probably multiple times now, all revolves around this. But the problem is most of you have seen it multiple times. Jim's seen it more times than he wants to even think about. Yeah. I do that. So I just pulled some things out, some points out. We'll go over a few of these points and let's just talk about it. Let's just discuss, because I think that's probably the best way to handle it. So what's driving the interest in CO2 refrigeration now? Well, ultimately, it does go back to the Kigali Amendment to the Montreal Protocol. That was basically where HFCs were added to the Montreal Protocol to phase down, not phase out, but a phase down. That led in the U.S. to the AIM Act, which is our own phase down of HFCs. And part of that is the technology transitions. And the fact that in these larger systems in particular, we have a GWP limit coming up of 150 for 200 pounds charged larger. We also have state level regulations. We have the things that are going on out in California and also Washington State. And now we have New York State trying to out California with their stuff. And something that Jim alluded to, I call it future proofing. I think, Jim, you called it retrofit proof. I'll call it future proof refrigerant choice because of further tightening GWP limits. And then ultimately, you start talking about the HFOs, maybe, possibly, PFAS and PFAS concerns. So polyfluoroalkylated substances. That those regulations could come into play and could restrict the use of HFOs coming up in the future. There's also a desire to avoid flammable refrigerants, especially on these larger systems. These smaller systems we've been talking about a little bit with propane, 150 gram systems, 300 gram, 500 gram. Safety measures for those systems are not bad. They're actually pretty easy to do. But if you start looking at what you have to do to use a flammable refrigerant in a very large system, particularly if any of that charge is going to be indoors, it starts to get pretty onerous. I mean, there's a lot of things to take care of there. And then also, there are heat reclaim and energy recovery opportunities with CO2 that you don't necessarily have with other refrigerants. That's going to be a smaller subset of users, but I think it is important, and I think that does help to drive CO2 adoption. So, questions, comments? Matt?
We have PFAS in our products, PFAS substances. And do we know what those are? And I guess my question is, who tracks that? I've been asked about that by.
Yep, we're starting to be asked more and more about that. One of the major problems with PFAS is there are many definitions of PFAS. And depending on what definition you use, it can encompass from as few as a few hundred substances to many thousands of substances. And the regulatory bodies out there that are doing things on PFAS are not in agreement, which is typical. State of Maine is probably right now the stickiest subject because they have come up with a definition of PFAS that is so broad that when they originally came up with it, best estimates were it incorporated somewhere around 14,400 substances. And to anyone that's going to try to determine whether there's any one of these 14,400 substances in their products, well, good luck. That's going to be tough. What we're doing right now is we're starting to put our products, or we will be putting our products into a database called CDX. This is a corporate sponsored thing. And it's basically a bill of substances, and it's going to make things a lot more, make reporting things a lot more easy and coming up in the future. But we're just undertaking the very first steps of that right now. So, like I said, it really does depend quite a lot on the definition of PFAS that you use. Anything else? Okay. All right. So, SNAP, Significant New Alternatives Policy, we're kind of done with eliminating refrigerants under the SNAP program because it was all about chlorinated refrigerants. So CFCs and HCFCs, they're all in effect gone now. But it's still the way the new refrigerants are approved for new and existing applications. So we do still have to pay a little bit of attention to what's going on with SNAP. So if we look under at SNAP right now, what today is CO2 approved for? What kind of applications today is CO2 already approved for? By the way, most of these have been in there for 10 years or more. Commercial refrigeration, supermarket rack systems, condensing units, standalone units, self-contained units, processing and dispensing equipment, ice skating rinks, industrial process refrigeration, industrial process air conditioning, cold storage warehouses, refrigerated transport, chillers, both centrifugal and positive displacement, and then non-mechanical heat transfer. So basically using CO2 as a secondary fluid. So we have all these applications already approved for CO2. So in other words, there's an awful lot of applications out there where if you really want to use CO2, you don't have to go through the SNAP approval process. You don't have to petition for a new SNAP approval for it. So that's another thing that's driving. Those things are, these are already pre-approved, and if you can figure out the design of it, you can move ahead with it. Is there anything missing on the list? Right now, I don't think there is. I did a check. I kind of double checked through some of the EPA SNAP tables, the approved refrigerant tables. One thing I was actually surprised was not there was residential and light commercial heating and air conditioning, and it's not there. I'm surprised at that. I thought it was. If somebody had asked me before I looked at that table, I would have told them the wrong thing, because I would have said, I think it is, but it's not. So I think that's a pretty clear. Now, there might be a couple of applications that are outside of our, realm of our business that I didn't put on there. The things that are, potentially within the realm of our business, they're up there.
What is non-mechanical?
That would be using CO2 as in like a pumped liquid overfeed type application. Yeah. Yeah. So that's there. Now that can include other things too. That could include things like organic Rankine cycle, energy recovery systems, things like that. That's a pretty broad category under EPA. So, all right. And then the other important thing is, how does CO2 fit into the codes and standards framework? Well, this is probably a bit of an oversimplification, but at the systems level standards, it's really more or less the same as most A1 refrigerants, because it is an A1 refrigerant. So under ASHRAE 15, which is the overall ASHRAE system safety standards, and then under UL 60335-2-40, which is the air conditioning, heat pump, dehumidifier standard, and also under 60335-2-89, which is the commercial refrigeration standard. It's essentially not treated any differently than any other A1 refrigerant. Now, when it comes to our products directly, the component level standards, there are definitely additional pressure safety requirements. And we've been dealing with those now for a while. So those are some things that Gordon's been dealing with directly, Andrew's been dealing with directly. There's just different ratings that we have to deal with primarily under UL 207, but also under UL 429. And things kind of fit kind of the same for ISO 14903, which of course we need potentially for European sales. It's still just based around the design pressures. So there's not a whole lot of difference. Like I said, it's the same at the system level, but at the component level, it's just allowing for the higher pressures. But being a non-flammable refrigerant, there really aren't any additional requirements there. We're running into all kinds of additional requirements on A2L refrigerants when it comes to gasket compatibility testing, things of that nature. And those are things that we really don't have to worry about that much any more than we do on any other A1 for CO2.